So worksheet number 2 is about decomposition reactions, which we just went over the generic format for on the graphic organizer. In a decomposition reaction, again, one single reactant forms multiple products. There's lots of different compounds that decompose, and I'm going to go through kind of one of each of these to help you out. Carbonates, which have the carbonate ion in them, hydroxides, chlorates, acids, which of course their cation is hydrogen, and oxides, which create oxygen ions, but really oxygen gas. So let's go on with this. So with a carbonate, it's going to decompose, making carbon dioxide gas. And then whatever metal is with the carbonate, remember we have metals on the front, that's our cation, and non-metals or a polyatomic ion on the back, that's our anion. So the metal that was attached to carbonate becomes attached to just oxygen. So we've got 3 oxygens in carbonate, 2 of them go off in the carbon dioxide gas when it's heated, and then the metal hooks up with the oxygen, okay, in whatever proportion it needs to balance charge, all that stuff. Hydroxides decompose into water and a metal oxide also. Chlorates are going to decompose, interestingly enough, into oxygen gas. Remember, it's diatomic, and a metal chloride. So the chlorine sticks around and attaches to the metal, whatever it is. Acids are going to decompose by forming water, which is kind of interesting. And whatever's left over, whatever the hydrogen was attached to make the acid, the remainder of the polyatomic ion, the anion, is going to get its own little self. Okay, again, I'll try and show you an example of that. Oxides are going to decompose, like I mentioned a little bit ago, into oxygen gas, and then typically the metal is left alone by itself, but not always. All right, so let's try a couple of these. There's multiple parts to this, so it's decomposition, single thing on the left side of the arrow. We're going to break into 2 or more things. So here's a carbonate. Carbonates are going to make carbon dioxide gas. And the metal is going to go with the other oxygen that was in the carbonate ion. So barium is in group 2, it's a +2. Oxygen is a -2, so very nicely we end up with BaO, barium oxide. And then the only thing left is to double check where we are. So you're going to have to come up with it's a solid, sorry, the formula for the reactant, the 2 products, and this one works out really nice. It's already balanced when we're done. 1 barium, 1 barium. Carbonate is CO2 plus an oxygen, so here's CO2 and an oxygen, so boom, this one's done. Okay, there's 2 more for you to try. The next one, it is hydroxides. So zinc, you might recall, is a +2. It's one of the transition metals that only ever has a single charge. Hydroxide's a -1. So you're going to want to put 2 of them in parentheses. When this decomposes, it's going to make zinc metal, and hydroxides make a metal oxide. So the oxygen and zinc are going to go together. And I think I forgot something. What did I forget? Oh, water. Sorry, hydroxides form water and a metal oxide. So this is going to be zinc oxide. There we go. Sorry about that. And water. So zinc oxide. That's the stuff you put on your nose to keep from getting sunburnt. And of course, water is, oh, I switched these up, forgive me. I'm just gonna write H2O again, is a liquid at room temperature. So let's check out our equation again. 1 zinc, 2 OHs. So remember hydroxide, hydroxide. So this is an O and an HHO. So that takes care of our 2 hydrogens and our 2 oxygens. And this one's done once we get it written properly. You have to remember to do the subscript too. All right, let's go to chlorates. With chlorates, you gotta watch out for charges for our transition metals. So nickel is Ni, of course. And chlorate is ClO3 and has a -1 charge. So you're gonna need 2 of them. You're gonna form oxygen gas. And you're gonna form nickel 2 chloride. So oxygen's diatomic. And of course it's a gas. And nickel 2 means it has a +2 charge, not 2 of them. Chlorine's always a -1, so we're gonna need a sub 2 here. So we've got a little bit of an issue. 1 nickel, that's not a problem. But 2 chlorines, so this is 2 ClO3s, so that's okay. We got 2 chlorines. But we have 2 times 3 or 6 oxygens. So 6 divided by 2 is 3. So again, this is ClOOO, ClOOO. I need to have 2 chlorines, which I do, and I need to have 6 oxygens as well on both sides. When an acid decomposes, you're going to make water, and then whatever's kind of left over, you go from there. So sulfuric acid, you'll have to look in your book if you don't know all your acid formulas. We're going to assume this is aqueous, but we could say it was a gas. H2SO4, and it's going to make water. And so what's going to be left over after there's water out of there? Well, the H2 and one of the oxygens goes away, and that leaves SO3. And you might recall that these are both non-metals, and so we're going to call this sulfur trioxide. All right. Last one I'll give you some help with, sodium. Sorry, not sodium. Let's do silver oxide, and then you can do aluminum oxide. Silver oxide is Ag2. Remember, silver is always only a +1 with oxygen. When it decomposes, oxides decompose into oxygen gas, and then the metal is left by itself. So obviously you've got 2 silvers here, so you're going to need at least 2 over here, but notice we get the oxygen problem, 2 and 1. So start by doing this. That takes care of oxygen, and then we have 2 times 2 or 4 silver atoms. So again, oxygen and silver. And that's how to do decomposition reactions.